So next what you need to do is to calculate the absolute value of uncertainties from the given relative values. For the case of mass flow rate, it will be measured mass flow rate 0.27 times its uncertainty, which is 2%. The answer is 5.4 times 10 to negative 3. For specific heat, it is its value 4.2 times 0.015. The answer is 0.063. The unit is kilojoules per kilogram per Kelvin. There's no need to do anything here because it's given in absolute value. Next step is to determine those partials in the main equations. So first one is going to be partial derivative of q dot with respect to m dot, which is simply looking at this equation is Cp times delta T. Next one is partial with respect to Cp, which is m dot delta T. And the last one is partial q dot with respect to delta T. And the answer is m dot Cp. Then we will plug in numbers in these. Cp is 4.2 times delta T, 12.7. The answer is 53.34. On m dot delta T is 0.27 times 12.7. Which is 3.429. And the last one, 0.27 times 4.2. $1.134. We also need to calculate q dot. I'm going to do it up here. So q dot is 0.27 times 4.2 times 12.7. Which is 14.402 kilowatts. That is our heat transfer rate. So back to this equation here, and we can plug in values and calculate uncertainty in Q dot. So instead of the radical sign, I'm going to use brackets. First term, partial with respect to m dot, which is 53.34 times the uncertainty for m dot, 5.4 times 10 to negative 3 squared plus next bracket partial with respect to CP is 3.429 times uncertainty for CP 0.063 squared plus partial with respect to delta T 1.134 times uncertainty for delta T is 0.5 squared. The entire thing we gotta calculate the square root of. I'm going to calculate each of those terms in the equation above separately and show you what can be learned from this in addition to just calculating the total uncertainty. So the first term is 0.083, the second one is 0.047, and the third one is 0.323. So the answer is 0.673 kilowatts. That's the uncertainty. So you can report Q dot as 14.402 plus minus 0.673 kilowatts, or plus minus 4.7%, which is calculated by dividing this to this and calculating the percentage. So looking at these three terms, this one, and this one, you see that the third one, 0.323, is significantly one order of magnitude bigger than the other two. So it means that this one, the last one, was due to delta T. So this one is the uncertainty share of delta T. This one was for CP, and the first one was for m dot. So comparing these three, you'll see that delta T measurement has the largest share in the uncertainty of the heat rate. So this is the additional information that I talked about. So by comparing these, you can tell that if you want to improve your results, you need to make improvement to your delta T measurements compared to M dot or CP. And CP has the lowest, is the smallest contribution to the overall uncertainty of heat rate.